Hello everyone, your radar contact and welcome to another VASaviation video. In this VASaviation lesson, we will go over the METAR and we will learn how to read and decode the data it contains. METARs are aviation routine weather reports. The abbreviation METAR stands for Meteorological Aerodrome or Airport Report. METARs are coding messages of the weather conditions at an airport at a given time. METARs are usually issued every half hour during the airport operating hours. We will read a METAR section by section and we will learn what its codes and symbols stand for. The first group that appears in a METAR is the identification of the weather report. Special weather reports can be issued under the code SPECI when significant changes occur, either improvement or deterioration, and will follow the same format as a regular METAR. The second group stands for the ICAO code of the aerodrome. In this example, we can see the airport is Asturias, Spain, Lima Echo Alpha Sierra. The next group is the date and time of the actual weather observation. The first two digits represent the date, followed by the time in hours and minutes according to the Universal Time Coordinated UTC and stated with the letter Z or Zulu. The direction and strength of wind is shown next. Direction is usually rounded up or down, and I find important to note this direction is where the wind is coming from. The speed of wind always follows that direction and will be shown with the letters KT standing for knots. If there are gusts of more than 10 knots in reference to the stated speed, the letter G appears before the gusting speed. If the direction of wind is variable and changing, then the letters VRB appear preceding the speed. As in the example, the wind is variable at 10 knots, gusting 20 knots. If the variability of the direction is known between two streams, a new group appears as shown in the example, stating the two streams the wind is moving in between and is identified as a V letter and the two streams on each side. If the wind is calm, then the code 0KT is used. Visibility is represented by the next group. If there is not much variability, the minimum visibility will be given. This horizontal visibility is measured in meters and will be read as kilometers. If the visibility is up to 10 kilometers or more, then the code 9999 is used. If the visibility is less than 50 meters, then the code 0000 is used. In some instances, we can also find the specific visibility at a runway threshold, also known as runway visual range or RVR. It is only given when either minimum horizontal visibility or RVR is less than 1,500 meters. This group starts with the letter R followed by the runway the RVR stands for, slash the visibility in meters at the threshold. If the RVR is more than the maximum value, then a P will precede the visibility. A letter can also be placed after the visibility to represent the trend that has been experienced recently. The letter U stands for an increasing of 100 meters or more in the last 10 minutes. A D stands for a decreasing in the same period of time. The letter N means there has been no tendency or change. The next section we encounter is the weather phenomena groups. These groups inform about what time of weather is at or near the airport at the time of the observation. You can see a complete table of codes and symbols used to describe the weather. The first column shows the intensity or proximity of the weather phenomena. Light is shown with a minus symbol and heavy with a plus symbol. In case of moderate weather phenomena, no symbol is applied. The letters VC stand for the vicinity but not at the observing point. The next column adds details of the weather phenomena. The most common you'll see are BC, which means patches and will be frequently added to describe fog, SH, which means shower and will be followed by the type of precipitation, and TS, which is thunderstorm. The last three columns represent weather phenomena regarding two types of precipitation, obscuration, or others. The precipitation column shows different kinds of precipitation and their codes. Most common ones might be RA for rain, SN for snow, or GR, which is hail. The next column classifies weather phenomena in terms of obscuration. These include BR for mist or brume, FG, which is fog, etc. Don't mistake mist obscuration code with the MI descriptor code. The last column shows all the weather phenomena which have not yet been included and are unusual or rarely used, but they are still important. All the codes in the table can be combined to represent a weather event in particular. For example, heavy shower of rain, or heavy shower of snow, or patches of fog. The definition of a thunderstorm is when a thunder has been heard and lightning observed within the last 10 minutes. Whenever a thunderstorm takes place, the letters TS are used and can be followed by precipitation if there is any. For example, TSRA stands for thunderstorms with rain. Cloud and sky coverage is the next section in a METAR. There are several cloud codes and prefixes which mean different types and amount of clouds in the sky. We must know that we divide the cloud coverage into eighths, also called octas. Depending on the cloud coverage, the amount of clouds may be classified as few, meaning 1 to 2 eighths of clouds, scattered, meaning 3 to 4 eighths, broken stands for 7 eighths, and overcast, which means complete cloud coverage. The height of the clouds will follow immediately after the amount. This will appear in hundreds of feet based on QFE or airport level. For example, broken clouds at 1,700 feet will appear as broken 017. Scattered clouds at 700 feet would appear as scattered 007. The other types of clouds that are present in the METAR are the significant convective clouds. These are cumulonimbus, CB, or towering cumulus, TCU. We can see in the example a layer of overcast at 2,000 feet with a convective cumulonimbus in it. If there is no clouds observed at the airfield, the code SKC, which means sky clear, will be shown, or the term NSC, which means no significant clouds, will appear if Cavalcade is not appropriate. If the sky is obscured and no cloud information can be given, then the vertical visibility will appear. The code for vertical visibility is VV and will be followed by the height in hundreds of feet. For example, a vertical visibility of 200 feet due to fog. If the vertical visibility cannot be reported, the code VV and 3 slashes will be given as shown in the example. The term Cavalcade is frequently used to determine that ceiling and visibility are okay. If Cavalcade is reported, it automatically replaces the visibility, RVR, weather, and cloud groups. However, there are some criteria which must be met in order to Cavalcade to be used. The visibility must be 10 kilometers or more. The lowest cloud ceiling must be no lower than either 5,000 feet or the highest minimum sector altitude, whichever is the greater. No cumulonimbus or similar significant weather phenomena must be present. If all these criteria are met, then the code Cavalcade will be reported in the METAR. The temperature and the dew point will be the next section we'll be looking at. This is simply a 2-digit number for the temperature and another 2 for dew point separated by a slash. These two values are shown in degrees Celsius. In the example, the temperature is 10 degrees Celsius and a dew point of 2 degrees Celsius. If either is negative, then the letter M appears ahead of the digits to represent minus. The closer these two temperatures are, the more probable is to encounter fog or rain at the airport. The next important figure of the METAR is the pressure, or QNH. The QNH is entered by the letter Q, followed by 4-digit numbers representing the actual pressure value in hectopascals. If the QNH is less than 1000 millibars, the first zero prevails, followed by the QNH value. For example, a QNH of 997 hectopascals will appear as Q0997. The QNH is always rounded down for safety reasons. A different pressure measurement can be given. Note that in the United States, the altimeter is given in inches of mercury and will appear as A, followed by 4-digit numbers. For example, A2992 stands for 29.92 inches of mercury. Another code used in METAR is RE, meaning recent significant weather has occurred within the last hour or since the last METAR, whichever is shorter. For example, RERA will appear to inform our recent rain at the observing point. The next important information we find in a METAR is the wind shear conditions. The code is WS, which will be followed by the details of runways or areas the wind shear has been observed. A trend forecast is attached at the end of the METAR and will be valid for the next 2 hours. The change can be reported either as becoming or temporarily. These two may be followed by a time period in hours and minutes. This time period can also be preceded by the codes from, till, or at. For example, this trend is reporting that temporarily from 10:20 Zulu to 12:20 Zulu, the visibility will decrease to 1000 meters and heavy showers of rain will take place. If there is no change forecast, the term NOSIG will appear. NOSIG stands for no significant changes expected within the next 2 hours. An equal sign will be seen at the end of the METAR to denote the end of the message. We finished the lesson about the METAR. I really hope you enjoyed the content and learned new things about the aviation world. If you have any questions related to this lesson or any other topic, don't hesitate and leave it right below on the comment section. It's VASaviation, frequency change approved, and see ya guys.